solving absolute value inequalities. There are only two types of absolute value inequalities. Let's generalize them. Here's the first one. Absolute value of P is less than or equal to K, where P is some type of expression and K is a constant. And the other type is the absolute value of P is greater than or equal to K. So the difference between the two types is the inequality. One's going to the left and the other one's going to the right. One other thing to note, the inequality here is less than or equal to, but this answer, the general answer that I'm going to write down, it could also have the less than symbol as well. So we're going to call this type 1, and we're going to call this type 2. The answer, the general answer for type 1 is as follows. We get the constant and we put a negative on it, and we're pointing the inequalities the same way as the type 1, and then just regular K. So the answer, the general answer for a type 1 inequality or absolute value inequality is this way: negative K less than P less than K, where of course negative K will be less than and equal to K. So that's type 1. So if you see type 1, that's how you answer it. Type 2 is a little bit more different. Type 2, the way you answer it is going to be P is going to be greater than or equal to K, same direction, the inequality, or, and we have to write or, P is less than or equal to negative K. So when we use negative K, we have to change the inequality. So that's type 1 and type 2. Okay, now let's try a type 1 problem. And let's see, let's say absolute value of x plus 2 is less than or equal to 8. Okay, so x plus 2 is going to be P, while the 8 is going to be K. And because it's going less than or to the left, less than or equal to, it's pointing to the left, it's a type 1 problem. So we're going to generalize, we're going to take this generalized answer and then put it on our problem. So negative K is negative 8, less than or equal to P, x plus 2, less than or equal to 8, which is just regular K. Okay, so now we have our general answer, but it's not quite finished. We need to isolate x. To do that, we do it kind of like solving for x in the equation. We subtract 2, but we subtract 2 on all sides, not only on the right, but also on the left. So we get negative 10 less than or equal to x less than or equal to 6. And that is our answer. Now, let's try another problem. So that's one problem right there. Let's try another problem here. Now let's do type 1 problem again, a little bit different. Let's say the absolute value of 4, take away 5x, and then close the absolute value, less than 16. So this is a type 1 because it's pointing to the left. It's a less than. Type 1 has less than or less than or equal to type of absolute value inequalities. So this part right here is P, and this is the constant. So we follow this particular pattern to solve it. So it's going to be negative 16 less than 4 take away 5x, and it's going to be less than 16. Okay, we use less than because that's what we are given, not less than or equal to. Now, how do I solve for this? Well, again, I need to isolate x in the middle. How do I do that? Well, we're going to subtract 4. In this case, we're going to subtract 4 on all sides. So here we got negative 20 less than, this will be negative 5x, less than, this will be 12. Okay. Now we need to isolate x. We need to get rid of this negative 5. So to do that, we need to divide everything by negative 5. But remember, when you divide by a negative number or multiply by a negative number, the inequalities change. So when we divide by negative 5, our inequality changes. And negative 20 over negative 5 is going to give me 4 is greater than x, which is greater than negative 12 over 5. Traditionally, we want the negative value on the left. So to do that, we switch these. If we're going to switch this over there, that means the inequalities will also have to switch. So let's rewrite it where negative 12 over 5 is on the left side, and then the inequalities will also have to change. And you can see negative 12 over 5 is less than 4. Nothing wrong with this problem here, with this answer, but traditionally you want to write the negative value here on the left. Okay, so that's the second problem. Let's do another problem. Now let's do a type 2 problem. So the absolute value of 3x minus 1, close it, and greater than 11. Okay, now how do I know it's a type 2? Well, it's greater than, right? Type 2s are greater than or equal to. So it's a type 2, and that means we're going to have 2 pieces. So here, this is P, and this is K. So we're going to write it out. 3x minus 1 is greater than 11. That's the first part. Or 3x minus 1, switch the inequality, and then the negative. Okay, let's write it nicer here. Negative 11. Okay, so we need to solve and isolate x. In this case, we're going to add 1. We have 3x is greater than 12. Divide by 3, and we have x is greater than 4. This one, we add 1. We have 3x is less than negative 10. And then we divide by 3. We got x is less than negative 10 over 3. So these are our 2 answers. 2 separate answers. So that's a type 2. Okay, and then we're going to try something different. Now let's do another one. X plus 5. The absolute value of x plus 5 less than or equal to 6. Okay, now what type is it? Type 1 or type 2? Well, it's type 1 because it's less than or equal to, right? The less than or the less than or equal to is a type 1. This right here is P, and here is K. Following this rule, to solve it, we get negative 6 less than or equal to x plus 5 less than or equal to 6. We need to isolate x. Well, we need to subtract 5 on all sides. And we have negative 11 less than or equal to x less than or equal to 1. Now, sometimes they'll ask for a number line. Let's do that. So here's a number line. Number line goes from negative 11 to 1. Now, a couple of tricks, and this is for type 1 and type 2. If, and we'll have a different color here, we'll try green. Okay, so if you have I don't like green. Okay, here we go. So let me give you a couple of tips here for the number line. If you have, this is for both, okay, hold on. Let me give you a couple of tips for the number line. This is for type 1 and type 2. Let's say we have less than or equal to, greater than or equal to. This will be represented as closed circles. Okay, and we'll get to know what that means. Closed circles. Also, less than or equal to, greater than or equal to is also represented as square brackets. And the square brackets just means that whatever number you have is included, okay, in this inequality. So that is very important. And then if you have less than or greater than, it's an open circle, and it's parentheses, meaning that it's not included. Okay, the number is not included when you put parentheses, or the circle. Whatever you circle means that that number is not included. Another thing, very quickly, if you have negative infinity, right, it's going to be, it's not bounded, so it's going to have parentheses as well. Either way, negative infinity or positive infinity. So those are kind of some tricks that we're going to need. All right, so let's continue here with this. Now, this is the answer, of course, but we want to graph it in a number line. So here we have negative 11, and we got 1. These are less than or equal to. So if we look over here at our key, it's a circle. It's a closed circle, meaning that negative 11 is included, and so is 1. And so what's going on between negative 11 and 1? Well, we're including all those numbers because x is between negative 11 and 1. So that's how you represent it. And here, of course, is x. Now, how do you represent it? By some type of set notation. A very quicker and faster way of writing these problems. Well, we're going to have to use the brackets because it's less than or equal to, the equality is there. So another way of representing this answer is by putting a bracket. Here we're going to put negative 11, comma, 1, and then close the bracket. Bracket means it's a closed circle, means it's less than or equal to. That negative 11 is included. So is the 1. 1 is a closed circle, and it's less than or equal to. 1 is included. So here we have 3 ways of representing this answer. Let's try another one. Now let's try the absolute value of x minus 3 is greater than 7. Now this one, it's going to be type 1 or type 2. Well, it's going to be type 2 because it's greater than. So here we have P, and this is K. Okay, so what do we got? We have to break it in two pieces. So it's going to be x minus 3 is greater than 7, or x minus 3 is less than 7, but it's going to be the opposite of that, right? Okay, that looks pretty good. Now we have to isolate x. I'm going to add 3 on both sides. X is greater than 10. Here we're going to add 3 on both sides. Here we have x is less than, what do we got here? Negative 4. Okay, so these are the answers. Now let's graph it. Here we have negative 4 on the left and 10 on the right. This is greater than or less than, right? We'll look at the key. It means an open circle. It means negative 4 is not included in the solution. Neither is 10. Okay, now we're going to shade. X is greater than 10. What number is greater than 10 or bigger than 10? Well, like something like 12, meaning on the right side of 10. And then x is less than negative 4. What does that mean? Well, values that are less than negative 4, meaning values on the left of it. Okay, and don't forget that this bar here is x, right? So that means there's something missing in the middle here. Okay, the set notation is a little bit more convoluted, but it's not too difficult. On the left side over here is negative infinity because it keeps on going. On the right side of this is positive infinity. Now negative infinity and positive infinity are not bounded, means you got to use parentheses. So we're going to go from the left here and go all the way to the right when we write the notation. So we're going to go all the way to the left. So it's going to be negative infinity, and that's not bounded. So we put parentheses, comma. It goes up to 4, negative 4. Now is negative 4, is that a closed circle or an open circle? It's open. It's open, so you got to put parentheses. Okay, we're going to put a gap here. And then just like the gap that's here. And then 10, that's where we start. It has to be parentheses. Why? Because it's not a closed circle, comma, and this goes on to infinity. Infinity is not bounded, so it's parentheses. Between the two, you put something called a union, and that's how you say it's part of the same problem. So if you want to know a little bit more about set notation, look up the other videos on YouTube. But this is the answer right here. And so is this one and that one. So there's a lot more towards solving absolute value inequalities than just placing them in these type 1 or type 2s. Sometimes they'll ask you to graph it or write the set notation for the answer.